Hi there, and welcome to another Puppety Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in Algebra 1 today, we're going to be looking at more quadratic word problems, which is found on Lesson 7 in Chapter 10 of your workbook. And again, if you don't have your workbook and you're here just for the video tutorial, I'm happy that you're here. It's nice to have you here. Okay. So let's get started on exercise number 2, where it says a hiker drops his compass from the top of a 100-foot cliff. The height of the compass as a function of time can be modeled by the equation h of t equals negative 16 t squared plus 100, where h of t is the height of the compass above the ground after t seconds. Interpret h of 1 equals 84, and now this word interpret means to explain in the context of the problem what these numbers mean. So if we look at the 1 inside those parentheses and we look at our equation inside those parentheses is a t. It says here that t is the number of seconds. So this starts off with at 1 second. Okay, after that, we go to this 84, and that's what the problem's equal to. And what is h of t equal to? The height of the compass above the ground. So at 1 second, the compass is now 84 feet above the ground. Okay. Now it says interpret the Y-intercept. So your Y-intercept of this problem is, you could tell because this is in standard form right here, and we've talked about how once it's in standard form, the number that's by itself, the constant, is your Y-intercept. Or you can know that by just substituting 0 in for t. And when you substitute 0 in for t, this cancels out pretty much, and you're just left with 100. So your y-intercept is 100. And to interpret that 100 feet, it says right here, is the height of the cliff from which the compass was dropped. Okay, lots of writing there. Now, part C says, how long will it take the compass to hit the ground? Justify your answer. So we're going to go back to this equation up here, negative 16 t squared plus 100, negative 16 t squared plus 100. And we want to know where it's going to hit the ground. So where is that thing going to be equal to 0? Now there's a couple ways to solve this. I'm going to solve it since we just have, that was my calculator, since we just have a t squared and we don't have a t also, I'm going to just solve this using inverse operations. So I'm going to go ahead and I'm going to subtract this 100 to the other side of the equation. And I'm going to be left with negative 16 t squared is equal to negative 100. Now, I want to divide both sides by that negative 16 so I can get inside to that t squared by itself. And 100, negative 100 divided by negative 16 is going to be a positive 6.25. Now my last step is going to be to take the square root of both sides, and my time is going to be, I believe, 2.5. And don't forget that you have a positive and negative answer to every square root, but because this is a real life situation and it's representing time and you can't have negative time, we're just going to have the positive solution there. So we're just going to have 2.5 seconds. So what does that mean, 2.5 seconds? It means that's how long it's going to take the compass to reach the ground. Now, knowing this stuff right here, it says sketch the path of the compass falling to the ground on the grid below. Well, from these 3 pieces of information, we know 3 points on the graph. Let's go back to part A. Part A tells us at 1 second, it's 84 feet above the ground. So let's go to 1 second, and we will go to 84 feet. So it says sketch. So again, we're estimating about 84 right there. Okay. In part B, it says the y-intercept is 100 feet. So we also know this point on the graph, 0, 100. And finally, we know where this compass is going to hit the ground, and that's going to be at 2.5 seconds. We're going to hit the ground. So based on these 3 points, we can make a nice smooth curve through these points to show the path the compass takes before hitting the ground. Okay? Now, if this video is helpful, we're done with exercise number 2 now, but if this video is helpful, please give it a thumbs up below to let me know that this video helped you. All right, stay tuned for exercise number 3.